in the mathematical form. Okay, is ft is here, 3ut t minus t plus 3, and here following that. Okay, and after you get this graph completely, the questions ask you to determine about its transform. Okay, is time transform. Minus 4 time reversal, 3 represent for the time scaling, and minus 6 represent for time shifting. Before we can take the time transform in this step, okay, you must plot the graph first. In this graph, observe them first, okay? In the previous lecture, I teach you the technique to sketch the graph. Okay, now, okay, can you see my slide?
Yes, sir.
Okay, can you see that? Okay. I'm afraid that I already share, but if the sometime is maybe it can be happen that it's a bug of the program that I should maybe close them and open it again, okay, to show you. But if you already see it, it's okay. Okay. Now the ft function can be separated into the to be the 4 sub-function. Okay, separate by plus and minus sign as I teach you in the previous step. But in this solution, I will go considerably fast, different from the previous that I teach you in each detail. Okay. The first one, the green one, TUT. Okay. UT, unit step, okay, unit step function, but it's processed by the time and the amplitude transform, okay? It's time is about the time shifting and about the amplitude scaling. In this case, you scale them first, okay? You take the amplitude scaling first and you take the time shifting later. The green graph, after you sketch them, clip you here. The next one is another simple UT, okay, but is have the time is have the amplitude reversal minus ut. It's a reversing here. Next one is have both, okay, is have the amplitude scaling and minus 3 represent for time shifting. It's here. You shift in the right hand side by 3 for this case. And the last one is have, okay, up to 3 transform minus 4 amplitudes, okay, for the blue one. It's a minus represent for the amplitude reversal, 5 represent for, okay, amplitude scaling, and minus 6 is for time shifting. Okay, you separate them at each piece of the signal, similarly to the previous. But in fact, in this case, in this example, is more easier than the previous one because it's have only ut function. It's not tut at the basic one. Okay, between them, okay, separate at each region clearly. We will give you here. Okay, after we get ft in this graph, we will process for the time transform. For the time transform, in this case, we have 3 transform. Okay, minus represent for time reversal, 3 represent for time scaling, and minus 6 represent for time shifting. For this case, okay, you must determine, okay, we plot the original ft first. For this case, you must take the time shifting first. You shift in the right hand side by 6 points. Okay, and next one, you take time scaling. Okay, scale by 3. Okay, the signal will be compressed by 3 times. Okay, and the last one, you take time reversal, flip respect to vertical axis. This thing is the final result that you get from time transform. Okay, you can see that this question, the difficulty of this question is like the chain rule. If you plot the graph wrong, okay, if you get ft wrong for the time transform, you already wrong too. Okay, you have nothing left. Okay, next one. Okay, the next one is a little bit more complicated than the previous. Okay, in this graph is have, okay, it's changing, is have here, it have the ramping function. Okay, therefore if it have the ramping function, okay, okay, it's required tut. Okay, in this case, how many mathematical term you require? It changing the slope one at this point is require 1 term. Changing the slope or changing the value, it require the second term. And the last one is changing the value again. Therefore, in this case, you have up to 3 terms for requirement. The first one is here, okay, for the green one, 4 TUT for this case. The next one, okay, how to, okay, why is the 4 TUT came from, okay, why the slope is equal to 4? I already present in the previous one. Okay, and the next one, the slope is changing from +4 to be -4. Therefore, the changing function will be -a. Okay, -a is about TUT, and TUT will be shift at 1. Therefore, it change to be T minus 1 UT minus 1. And the last one require another one function at this point. Change the slope from -4 to be 0. The difference of the slope equal to +4. Okay, you have 4 terms. You have 3 mathematical terms. Show you in here. Slide. The orange one is here in the slide, and the last one is a pink one. Okay, in this case, it's a little bit more complicated than the previous example. In the previous example, the signal is already in the flat graph. It have only UT function. But in this graph, the basis of them is already in the TUT function form. Okay. The next one, if the function is a periodic, if it's periodic, okay, the same as the previous. Okay, you use this term, you cut only one period of this graph, and this term F1 is already can write from this mathematical equation. From the previous practice, we have this equation, and therefore the top one, you only require the summation starting from -infinity. You have infinity in power. Okay, starting from -infinity, k starting from -infinity to +infinity, periodic one, and f1t equal to this form. Okay, next one determines, okay, given the part of the signal. In this case is this question, the objective of this question will provide you a little bit more understand how to manipulate adding, subtracting of the signal, and know about the even and the odd part. Okay, the overall signal will provide you to be here. Okay. Okay, the signal is xt. Xt give you here, and the even part of the xt in the right hand side is here. You know that the even part of the signal in the left hand and in the right hand must be identical. Okay, therefore, 4 times greater than 0, the signals, okay, the even part of them is equal to here, and the odd part, okay, you know that the functions, okay, in you know only the function 4 times greater than 0. Okay, you know that the overall signal xt equal to the even part add with the odd part, or in another point of view, the odd part equal to xt subtract with the even part. You subtract point by point, okay, in each region zone, and in this case it will be give you here. Okay, the way to subtract the graph in the graphical point of view, you already know. I already teach you in the previous step. Okay, in the previous lecture. Next one, you would like to know about the information in the left hand side. In this case, you know only xc, x even, and x odd only for the right hand side graph, or for time greater than 0. Now we start at even function. The even function is the symmetry. Okay, symmetry for time less than 0 and time greater than 0. Therefore, we can plot the even function first. Time less than 0 and time greater than 0 must be symmetry. Okay, therefore the function of the even must be here. Okay, must be shown. Now, after you know here, and the odd function is the same. It's close similarly to the even, but its symmetry respect to original axis. Okay, original axis. Okay, therefore x minus t equal to x minus xt here. Okay, after you get here, you already get the even function for time less than 0 and the odd function for time less than 0. You add between the pink graph and the green graph for time less than 0. Okay, you add them. Okay, add them point by point. Okay, add them point by point. After you adding them, keep you here. Okay, therefore the overall function will be here. Okay, you erase them. Okay, this is in the overall function. You can see that the question maybe give you the partial of the even part or odd part. Okay, and maybe partial of the original signal, and ask you for all. Ask you for all. You extract the information step by step. Okay, after that it's not finished. Okay, the question asks you to express the signal in the mathematics point of view. I don't show you in the detail where it came from, but I show you only this solution. If you try to do by yourself, you already know where it came from. Okay, where it came from. Now, the next one, okay, we have another tools, okay, topic left, okay, the continuous time system and the property of the CT, LTI, CT, continuous time system, okay. The continuous time system, what is the system? The system is a process for which cause and the effects relation exists. The cause is the system input signal, okay, or input, okay. Effect is the output, also called the system output signal. The relationship between the input and the output is mathematically expressed and is modeled as the equation. In general, we vigorously model the system by using the differential equation. Okay, for why we don't model by a simple algebraic equation, because the simple algebraic equation in general, okay, it have the lower accuracy than the differential equation. Okay, therefore we try to use that. Even though we have the more mathematical complex, more complex and more accuracy than the normal differential equation, but we frequently use the differential equation to model about the system or model about the natural phenomena, because we in the engineering and in the mathematics society, okay, we have a lot of the solution in the differential equation form. Therefore, you can see that in almost all field, okay, in the science fields, okay, or engineering, science, physics, and so on, you must study calculus first, okay, will lead you that calculus 1, calculus 2, that lead you to understand how to solve and how to model the differential equations, okay. Now, in the general, the system can be represented by a block diagram as shown you in the following figure. The block diagram is here. Okay, the input is x, the system is t, output equal to the process of the x. Okay, the system equation can write to be yt equal to t xt, where t is the system transformation, such as the differential equation or a simple time transform or amplitude transform. Okay. Now, two links between this idea and the real physics thing. Okay. In the engineering, we don't want to know how complicated, how many transistors in the system of amp, also on in here. We would like to know what about the output in the mathematical function of the input. Okay. Now, in the real case, we figure models the system in the real physics phenomena or real physics system. Given the system shown in the following figure, determines the system equations where Vt is the system input and VL is the system output. You can see that in this case, if we feed, okay, the input is V that you feed to be here, okay, is the voltage source, okay. The output is the inductor's voltage, okay. In this case, we can model this relationship between the input and the output by apply the KVL or the Kirchhoff voltage law around this part. Okay, you mean minus first is minus V. Okay, plus, okay, VR is plus because the current flow in here, VR, and VL is plus, okay, equal to 0. Okay, you substitute everything in the term of the current. Okay, V input is a fix. Okay, the voltage of the inductors can write from the Ohm's law I R. Okay, R. Okay, I R. I R. Okay. And the voltage across the inductor can express into here L di by dt. You can see that this is a single equation that you can express the relationship between the input and the output here, and the voltage of the output can write them in the term of the inductor voltage L di by dt. Okay. Now, in the general point of view, this diagram, okay, this circuit diagram can represent by a simple block diagram in here. Okay, you know V input, okay, output equal to the VL, okay, the system is here, can express in the differential equation model, okay, and the output can write them in the term of the current in here that relate between the system and the output is. You can see that in this case, the block diagram does not show that how many transistors you have, inductor you have, or the voltage source you have. You see only the black box, okay, black box. You know only the input, okay, in the function of time. You know the output will be in the function of time, and the relationship links between the input and the output. The system is the key parameter to ring between each element, each parameter in this case is the inductor current IL. If you get IL, you can determine IL from V, okay? You can find VL2. The interconnection system. The graphical representation of the system can be shown you in here. Okay, if a simple system, okay, you have a single input, okay, feed to the system, the output equal to the process of the input, okay, or if the system is only process only in the addition between 2 or 3 signal, okay, is use the adding node in here, okay, or the summing junction, okay, yt equal to x1 plus x2 plus x3, or the product junction. The product junction, we may use the circles identification to multiply between 2 input, x1 and x2 is here. The parallel connection is if we have two block, okay, block 1, system 1 and system 2. Okay, if both block maybe the same, okay, or maybe different, okay. Okay, the outputs y1 equal to the process of the block 1 from the input, and y2 equal to the process of the block 2 of the input is, okay, show you in here. Therefore, in the overall point of view, okay, sometimes in the engineering, we don't want to know how many blocks inside here. We want to know only input, we want to know only output, and we want to know only the equivalent transformation of the input is, or the equivalent process of the input is. We will extract the how many input in here, or what about the detail of the input in the case that we would like to fix or modify the system, okay. But in the overall point of view, we frequently to know that only y equal to transformation of xt over here. We don't want to know how many sub input in this side, okay. Or in the series connection or the cascade connection, yeah, it will be have two block, but it's not connect in the parallel. It will be connect in the series. It means the signal will be sent to the system 1 and feed to the system 2 radar, okay. The result here. The example of this block diagram is very simple. For example, when you take the senior projects, okay, you have the signal from the controller, okay, to drive the motor in the system 2. Unfortunately, that the signal that generate from the microcontroller is have a 2 field volt, okay, is have a too little signal, okay, it's not strong enough to drive the motor. You must send them or amplify them in the amplifier circuit first, okay. Therefore, the system 1 maybe amplify the signal that generate from the microcontroller and send them to the motor later, okay, to control them. Yeah, but in the engineering point of view, sometimes we don't want to know, okay, how many sub block in here. We want to know if the input is here, if the input from the microcontroller is 2 volt, 5 volt, or 0.2 volt, okay. What happens, okay, how long that you can maybe can walk or maybe can run, okay, if your system or if your project is maybe about the car, okay, and the motor is used to drive, okay, the wheel, okay. In the overall point of view, okay, in the abstract point of view, if I order you to determine the output yt as the function of the input and the system transformation of the following figures, you write y3 in the term of x and in the term of its subfunction in here. You can write them in each step. Y3 equal to y1 plus y2, y1 plus y2, and y1 equal to the transformation of x, okay, transformation 1, t1 x, okay, y2 equal to transformation of the block 2, okay, t2 and x, okay. Next one, you express, okay, y4 equal to the transformation t3 y3, t3 y3, but y3 you express in the previous step in the pink term, okay, in the term of y1 and y2, and the real input is xt, okay. Substitute them in y4, you get here. The next one, in the overall output, y equal to y4 plus y5, y pro plus y5, okay, multiply them, okay. You can see that multiply between them, okay. Therefore, you substitute y4 in here, y5 will be equal to the transformation of the block 4, okay, and the real input is, okay. This is in the abstract point of view. In the near futures, okay, instead we use T1, T2, T3, T4. We maybe substitute them in the real system, okay. In the abstract design, okay, in the theoretical designing, okay, the system can separate into 3 groups, depend on its operator in the mathematical point of view. The first one is you multiply with the constant, or you use like about the amplitude transform, okay. We call them proportional P, okay. It means the process that only multiply the proportional value or proportional constant to the input. The second one is you differentiate them, okay. You differentiate the input is, okay. And the third one, you integrate the input. Therefore, the differentiate we use D, the integrate we use the symbol I. Therefore, the general system is called PID, the proportional integration and differentiation. Okay, it's only represented by 3 operators mainly. You can express the other real physics model by a simple block diagram by 3 of these simple block diagram: proportional, integrator, and differentiator. Another next structure of the system that we frequently found is the feedback control system. The feedback control system is a very important system that connection that is frequently used in the automatic control. The automatic control is mean the control without the human being intervention. Okay. The block diagram of the basic feedback control will be shown you in this diagram, okay, in this figure. Okay. The controller is implemented by the microprocessor or the microcontrollers, okay, that it have the signal sent to them, okay. In general, the controller already have the sensor in itself, okay. Therefore, if you use a common controller, the sensor is maybe the temperature sensor, the thermal sensor, the motion sensor, the gyro sensor, and so on. Okay. Now, in order to make you really understand about this idea of, okay, is have the plan. The plan is a process that you would like to control, okay. The sensor is the, okay, that you use this. When you set them, you use the sensor at the left frame. Now, in order to give you more understand, okay, I will show you some example. When you go to the, maybe when you if you go to the ABAC University and you go home, okay, the first step you do when you go to the dorm or go to the condominium is you open the air condition, right? The air condition. You maybe set the temperature to be 25 Celsius, okay? 25 is sent into XT, yeah, 25 Celsius, okay? But the real temperature is measured from the air condition sensor. The modern air condition already have the thermal sensor, okay? The sensor will be measured in the room temperature, okay? If the room temperature is 30 Celsius or 35, depend on each case, okay? 30 or 35 Celsius. You can check that, okay? The thing that you set is 25, but the real temperature is 30 or 35 Celsius. Therefore, it has some difference between the thing that you set and the real temperature. The error is here. It's sent to the controller. If it has some error, if the error is not 0, it means the thing that you set is not meet. Therefore, the microcontroller will be send the signal to the plan. The plan in this case is the compressor to reduce the room temperature at full speed, at full rate. Okay. Okay. The thing that it generates is the cool air. Okay. Okay, the cool temperatures. Okay, now it will be rechecked it again. Okay, the sensor will be rechecked it again. If the room temperature is only reduced to be 20 Celsius, 27. If it's 27, it's still higher than 25. It has some error in here. Therefore, the controller will be still send the signal to the compressor to working mode. Yeah, until the room temperature is reduced to be 25 Celsius. If it's 25 Celsius, it's already missed, okay? The thing that you set 25, it have no error in here. If it have no error, it means the controller don't receive, it receives that the signal is already, the room temperature is already matched to your design. The controller will be send the signal to stop the plant or to stop the compressor, okay, for a while. Okay, when the compressor is stopped, okay, the room temperature is increased due to the heat propagation from outside room to inside room. Okay, and if the temperature reached to be 21 26 Celsius, okay, 26, it increased by 1 temperature, okay, 1 Celsius. It's checking again. If the temperature that you set is different from the real temperature, the thing that you set is 25, the really is 26, okay, it have one in error. It send the signal to the controller, and the controller will be control the compressor to working, to restart and work again. Okay, the routine is about here. Therefore, when you go to the condominium or room, you can see that the compressor that is work, okay, when in generally when the compressor is work, is it have a noises, okay, sound, okay, but you can reason that the noisy sound is not generated at all time, right? It may be generated 30 minutes to cool down your room, okay. If your room already meet the requirement, okay, the controller will be stop operating in the compressor. Not only to save the compressor, but it can save the electric bill, okay, electric power. The plant is the process, the the physical system that used to control, okay. The controller is the physical system that is searched by the designing engineering in order to give the total system certain design characteristics, and the sensor is the physical system that measure the signal to be controlled. And you can see that today a lot of the equipment is already so smart. That's why it uses the feedback control. That's why we call them the automatics. Okay. Another one application that you can see, but it's very complicated, is the self-driving automobile. You may be saying that, hey, it's a Hollywood movie, not the real thing. If some of you used to listen or see the news, the Tesla, the modern models, okay, have the ability to drive automatically. Okay, even though it's not perfectly, okay, it maybe have some bug, okay, but in some case it's very powerful. I used to read the news, okay, that maybe 6 months before, okay, is the owner of the Tesla will be maybe go to work in the morning. Unfortunately, that, okay, that sky is a heart attack, okay, it's a shock, okay, is oh, he do so. The last thing is he set the automobiles, okay, automatically, and told the automobile to go to the hospital, okay. The automobiles, okay, the Tesla model can go to the hospital, and the sky can be saved by the hospital and by the physician in time. You can see that, especially when you are sick, or maybe if you are in the near futures, you maybe go to marry, okay, you maybe have the wife, if wife is already alone, and if she is pregnant, okay, if your baby he start to birth, okay, he start to pregnant, what happened? I think she cannot drive the car by herself, right? But if you have the automatic automobile, it's very good one, right? She only try to carry herself to the car and send the car go to hospital, okay, even though it's not perfectly, but it's a good one, okay. A lot of things, you know, that maybe seem, okay, like the Windows version 1, like the DOS version 1, or like the Android version 1. Everything is not perfect, but it's working, okay. In the near future, okay, it will develop more and more in both sensor, in both AI, and so on, to make them more practical. Yeah. In the engineering point of view, we would like to explain the analysis idea that what about the difference that relate between each signal in the mathematical function. The error will be in the form of the x subtract with y3. Y3 is the sensor, is T3 and y. You can see that in this case, you can substitute them. Y equal to, okay, the y that process from the errors, okay, is in the form of T1, T2, and the error signal. You substitute the error back into y, you will get the output will be, you can see that y output will be in the function of the input x and in the function of itself. Yeah, the general feedback system case, the system output is mathematically expressed as the function of the both the system input and the system output. Okay. Okay. For the one last topic is here, the property of the CT system, the continuous system. This section defines the property or the characteristic of this continuous system. The property defined can be used to test the mathematically the continuous time system in order to determine its property. Now, let xt is the input of the system and the yt is the output signal of the system. You can write the relationship between xt and yt is here. Xt will produce yt. Okay, this notation is called xt produce yt and can be present at the following block diagram. Okay, I can write in the general block diagram. To feed xt into here, the system and the output is here. Okay. This section we will concentrate only on the property is mean the mathematics property. Okay, the section presents 6 mathematics property of the continuous system: the memory, the causality, time invariant, invertibility, stability, and linearity. The first one is the memory. If the system output at time t0 or y t0 depend on the system input value other than xt0, then the system is memory. Otherwise, the system is memoryless. Okay, a system which is a memory is called the dynamic system, and the system which is a memoryless is called a static system. Okay, it means when you would like to check that the system is memory or non-memory, it means the system is already in the time shifting version or not. If it's not, it means the system is memoryless. Okay, you can see that in this case, yt at time t depend only on at that time. Therefore, the system is memoryless because it's not in the time shifting version. Okay, but the second one is here. If xt is here, yt equal to x squared t is still square, right? Multiplied by xt, okay, is still not in the time shifting version. Therefore, the system is still the memoryless too. Okay, the first one, the third one is here. Yt equal to xt plus 5, 3 plus 5. You can see that yt at the time did not depend on this current time, but depend on the other time. Therefore, in this case, the system is memory, is in the time shifting version. Okay. What about the idea of the memoryless system? The memoryless system is mean the system that can have no buffer inside it. Okay. Therefore, if you feed the input now, the output will be generated immediately. Okay. You cannot store the input is. Okay. And you cannot use the history of the input or the future of the input to generate the output is. Okay. Now, the next one, yt equal to the integrate input signal from -infinity to now. Okay, xt is here. Therefore, in this case, the system is have the required the others input at the other time. Therefore, it's memory. The invertibility. If the distinct system input xt produce the distinct system output yt, then the system is invertible. For the invertible system, the system input xt can be determined uniquely from its system output yt. Okay, it means you can write in generally the equation will be expressed y in the term of x clearly. Okay, now if you write them reversely, you write x in the term of y clearly, one by one. Okay, you can state that the system is invertible. For example, here xt can write them in the term of y. For this case, xt equal to yt divided by 5 clearly. If you change y, if you change x, y will be changed too. Okay, or if you change y, x will be changed too. Okay, now in another case, okay, in some case, okay, in this case is yt equal to x squared t. Yt equal to x squared t, you can see that when you write x in the term of y, you cannot write them clearly. Okay, for example, if it have 2 or 3 input and generate the same output, okay, in this case you cannot invert them, because when you measure the output is, you don't know what about the real input is. For example, if the output equal to 4 for this case, if the output equal to 4, you don't know what about the real input is. The input may be 2 or maybe -2. Okay, you don't know what about that. Therefore, in this case, it's not invert. Okay, non-invertible. The invertible system is the second system that when cascade with the system T yield the identity system. The identity system is the system for which the output is equal to its input is. Yeah, it's a reverse process. Yeah, if you have the process one system, okay, you send them to the inward process, okay, it will be cancel the effect of the first one. Seems that the signal, the inputs don't process anything in here. Yeah, the identity system do nothing. Okay, do nothing. The next one is the causality. If the system output at time t0 or y t0 depend on the system input value only for the time less than t0, then the system is called the causal. A system within the causal is called a non-anticipatory system. All real physical system must be causal. Okay, the idea of the causal is very simple. The causal is mean the output depend on the input at that time or in the history. It's impossible that the current output depend on the input in the future or in the tomorrow. Therefore, all physics system is already causal. Okay, yeah. In the mathematical analysis, okay, how to checking them is mean if the system output depend on the input at that time, you can see that it's a causal. Okay, and in fact, in this case, the system is already memoryless. Yeah. The second one is here, the outputs, okay, depend on the input in the history. Okay, you shift by 3 in the history. Therefore, in this case, the system is called the causal, but this system is non-memory. Okay, it's a memory. Sorry, it's a memory. Okay. Next one is another case. Okay, if the yt equal to x 3 plus 5, 3 plus 5 is mean x 3 plus 5 is a future. It's a future. The current output depend on the future. It is possible. Therefore, this system is non-causal. Okay. Or you integrate them from minus infinity to now. Okay, it depends on all value in the history. It's still causal. Causality. The next one is the stability. If the system output yt remain bound for any bounded system input xt, then the system is called the BIBO stable or the bound input, bound output here. It means if you feed the finite input to the system, the output must be bound or must be not infinity. Okay. How to checking that the system, the input is bound or not? You find the peak of them or the maximum of them in this case. If the maximum m in this case is less than infinity, it's not infinity. Okay. If the input is not infinity, feed into your system. Okay. The output must be finite too. Okay. Therefore, for the BIBO stable signal, okay, the output must be bound to. Okay. Some of you may be thinking that, hey, if you feed the finite input, it's impossible that the system will be generate the unstable signal. No. In some case, it can. Yeah. Okay. I will show you in okay, some example. Okay, I will plot this. Wait a minute. Hello, can you see my whiteboard?
Yes.
Okay. In this case, if you fix the input here, I'll put this here. Okay, if the system equal to 1 divided by x, okay, 1 divided by x, okay. If you fix if the input equal to 0, what happened? The output equal to 0 is finite, right? The finite one, okay. Output equal to 1 divided by 0, give you infinity. You can see that. In some case, okay, you feed the finite input, the output may be infinity. Therefore, in this case, we call them unstable. Okay, unstable. Okay, we go back to the slide. Is here. Okay. Now, in order to demonstrate, okay, when I ask you the system is stable or not, also on or not, okay, you must prove them, follow this example that I give it to you. Okay. Okay. Checking that the system is stable or not. Yt equal to x squared t. Okay, x squared. If the input is finite, okay, if the maximum of them equal to m is mean is maybe very large value. Okay, we don't care. But if it's not infinity, it's okay. Okay, m is okay. X must be less than m. Therefore, yt, the maximum of the y equal to m square, right? Equal to less than m square. Less than m square. If m is finite, m square is finite too. Therefore, in this case, yt equal to x square t is DIBO stable. Okay. Or the case that is unstable, okay, ut. The club ut is here. Okay. For time, you can see that in this case, ut is constantly, and what happened? The function will be integrate the club. Integrate the club. The more you integrate, okay, ut, the height of them equal to 1, the y of them is infinity, right? The y of this club infinity. When you integrate them, it means you determine the area under this club, and the result will be infinity. Therefore, if the output equal to infinity, it means the system is unstable. You can see that in this case, the input is unit step. The maximum of the unit step is 1. Okay. And the output will be infinity. If the output is infinity, we can conclude that in this case, the system is non-BIBO stable. Okay. The next one, if the system input xt is the time shifting, produce the system output yt minus t naught, that is the same time shifting, then the system is time invariant. It's time invariant. It means if xt produce yt, if you shift the xt by t naught, output must be have the same time shifting version of t naught too. Okay. How to check them? We can check the time invariant by you process the system first and shift them later, or you delay them first and process them later. Okay. If the result will be equal, it is identical, you can conclude that the system is time invariant. Unless the system is time varying. For example, yt equal to exponential xt. Exponential xt, you process them first. If you fit xt into them, the output equal to the exponential xt. And every t that you have, you shift them by t naught. Okay, the final result equal to the exponential xt minus t naught. Okay, the next one. Okay, you shift them first. Okay, xt equal to xt minus t naught, and you process them. Okay, process here exponential xt minus t naught here. You can see that in this case, the output of both of them is identical. If it's identical, you can state that the system is time invariant. Okay, but for another case, for the time reversal in this case, yt equal to x minus t. Okay, the time reversal is the time invariant or not, checking them first. Okay, process them first. Process xt, you get the time reversal, and you shift them after that. Or you shift them first. You shift them first. Okay, and process them. The result, you can see that the result is not equal. If the result is not equal, it means the system is time varying. We can conclude that, okay, the time reversal transform is not time invariant, it's time varying process. The last one, if the system satisfies the principle of superposition of the additivity and homogeneity property, then the system is called the linear. What about the principle of superposition? The system satisfies the principle of superposition if the input and the output can be following this condition. If you have x1, okay, the feed to the system, you produce y1. If you feed x2, output will be produce y2. If you feed x1 plus x2 at the same time, okay, feed to the system, output must be expressed or must be rewrite in terms of y1 and y2. You multiply with the constant a1 and a2. Okay. Now, for the real case, okay, I will show you checking that the system is a linear or not. Yt equal to 3xt. Yt equal to 3xt. If you feed x1, okay, to the system, any signal, any input here, you amplify by 3. Okay. Y1 equal to 3x1. Okay. Y2 equal to here, you feed y2 to the system, okay, sorry, you feed x2 to the system, y2 equal to 3x2. Yeah, if you feed x1 and x2, okay, all process multiply by 3, multiply by t. You distribute 3 in here, you group them, you can observe that 3x1 give you y1, okay, 3x2 give you y2, and you can conclude that, okay, you can see that if you feed x1 plus x2 give you y1 plus y2. In this case, you can say that the system is linear. Okay, but in another case, okay, determine the whether the system described by yt equal to x squared t is a linear or non-linear. Okay, you feed x1, y1 equal to the input square. In this case, the input is x1, you get x1 square. You feed x2, output equal to the input square. The input in this case x2 square, give you x2 square. Yeah, now, if you feed x1 and x2, if you take square, okay, you feed x1 and x2 at the same time, you take square of them, right? You take square of them. Sorry for this. It may be a little bit error in here. I will fix that. Sorry. Okay. In the book, it's already correct one, but the slide is not revised. Okay, it don't change. Okay. Okay. Now you feed x1 plus x2 square. Okay, from the quadratic expansion, you already know x1 plus x2 square give you x1 square, x2 square, 2x1, x2 is here. Okay, and you can see that from this equation, you get that x1 square give you y1, right? x1 square give you y1. x2 square give you y2. Okay. Now in this case, okay, in the left hand, okay, in the right hand side, give you, okay, y1 square, y1 square, y2 square, and 2x1, x2, not equal to y1 and y2. Therefore, we can conclude that the square is non-linear. Okay, the square operator is non-linear. Now, in the real case, real situation, the question frequently asked provide you the system in here. The system yt equal to psi 2t xt, and ask you that the system is whether memory rate invertible, causal stable, time invariant, or linear or not. Okay. You check each step first. Okay. The system is memory. Why is memory? You checking that the input. Okay. Yt is depend only on x at that time, at that t. It's not in the time shifting version of xt. Okay. Therefore, the system is memory because the system output yt is a function of the system input at only the present time xt, and the output is not depend on t minus t naught or t plus t naught. It's not in the time shifting version. The system is non-invertible because The distinct system input xt may produce the same system outputs yt, such as, yeah, cannot invertible because in the case that if psi t equal to 0, whether the input is, okay, the input is 0, it means you maybe have so many different input, but produce the same output is. Therefore, if you know what about the real output is, okay, for example, if the output equal to 0, you don't know what about the input is. The input maybe have there are many possibilities. Okay, it's non-invertible. The system is a causal. If it already memoryless, the system is already causal because the output is only depend on the presence of the input is. Okay, and next one, checking that the system is stable or not. Therefore, you must checking that if the input is stable. If the input is stable, it means the maximum of the input must be less than m. What about the output is? If the output is not infinity, it's in the term of m, it means you can conclude that the system is stable. In this case, we have two terms, psi and x. The maximum of x is m. The maximum of psi is only 1. It's only 1. Therefore, in this case, the maximum of y equal to must be less than m. If it's less than m, it means it's finite. If it's finite, you can state that the system is the BIBO stable because the system output is bounded for all bound system input as following proof. Okay, and the next one, checking that the system is time invariant or not. Okay, you must process them first. Okay, you process them. Okay, if you feed xt, you get psi 2t xt, and you shift every t by t naught, okay, or you shift them first. You shift them first. Okay, shift every t by, yeah, t and t naught, and you process them. Okay, when you process them, you get here psi 2t and t. You can see that two things is different. Okay, if it's different, it means it's time varying. It's time varying. The system is time varying because the system input x t minus t naught, that is the time shifted, does not produce the system output y t minus t naught, that is the same time shifting version. Okay. The one, checking that the system is a linear or not. Linear is mean you feed x1, y1. You feed x2, y2. What about y1? Y1 in this case is you feed x1 into them. Okay, y1 equal to psi t, x1t. Okay, you feed x2, y2 equal to psi t, x2t. If you feed x1 plus x2 is equal to psi t multiplied with the summation of x1 plus x2 and expanded. Okay, after you expand them, okay, psi t xt, psi t xt, psi t x1, sorry, psi t x1 give you y1. Okay, psi t x2t give you y2, and you can conclude that, okay, in the form of x1 plus x2 equal to y1 plus y2. Okay, take the summation. Okay, you can state that this equation is true. Therefore, the system is linear. The system is linear because the system satisfies the property of the superposition of the additivity and homogeneity. Okay. Is all for this chapter, and we have another 30 minutes to, okay, to take a little bit exercise. Wait a minute.